Hi, so this is my video on 10.5 on the second type of conic section, which is the ellipse. So when we did parabolas, we defined the parabola has a governing property. And what's the governing property? The distance between a moving point on the parabola and a fixed point, the focus, is equal to the distance from that point to the fixed line, directrix. And then we use that to find the equation. The ellipse actually is kind of different. So for ellipse, what you do is, so imagine a point which is moving on an ellipse, right? So the governing property is that there are not, and like unlike before, right? We don't have a single focus, but we have two focuses. We call them foci. So F1 and F2. So the point moves so that if you take the distance from the point to one of the focus, say this distance, right here, and the distance from the point to the other focus, right, which is this, and if you take the sum of those two distances, the sum is always constant. So, for example, here you can see the distance to F1 is larger and the distance to F2 is smaller. But so that's if you take the sum, you get a certain sum. But if you look at if the point comes here, the distance to f1 is smaller and the distance to f2 is larger, but the sum still remains a constant. So no matter where it goes along this path, the sum of the distances remain constant. So we are trying to put that into an equation form. So what we do is, for convenience, we are going to take the xy axis and put them right in the middle of these 2 points. We can do that. We can put the xy axis anywhere. So right in the middle of the f1 and f2, we put the xy axis, right? Okay, and then we get things like that because this right in the middle. The foci are symmetric, negative c0 and positive z0, right? And the point we can call it xy. So we use the distance formula, and then what do we get? We take the distance from P to this point, which is what? X minus C, which is x plus C squared, right? X2 minus x1 squared plus y2 minus y1 squared. So y minus y squared, y minus 0 squared. That's the distance from the point to F1. And likewise, the distance from point to x2 is this, x minus C squared plus y minus 0 squared, and then take the square root, and that is the total distance. This distance is this distance is this, and their sum has to be constant. We call the constant 2a. There is a reason for that. The reason for that is actually you will see later, but a is a constant, so 2a is also a constant. So this is the constant, right? Okay. So now what we are going to do is we are going to have a kind of a radical equation here. So when you have two radicals, you know what to do. You isolate one radical. So I'm going to isolate this radical, the second one, and take the first radical to the other side. So I get 2a minus the first radical that you can see here. Now I'm going to square both sides, right? And when I square both sides, right, what happens, right? When I square this side, right, I get x minus c squared plus y squared squared. The radical goes away, right? And when I square this side, I get this has two parts. So the square of the first one, which is 4a squared, minus product of the middle term, that means twice the middle term, minus 2 times 2a is 4a, and there's this radical. And then the square of the second term, which is x, the radical goes away, and you just get x plus c squared plus y squared. On the left hand side, actually, what will happen is we will get x minus c squared plus y squared because the radical goes away. So if you take x minus c squared plus y squared, what do you get? X squared minus 2xc plus c squared plus y squared, and that's this. X squared minus 2xc plus c squared plus y squared. And on the right hand side, you have what I told was 4a squared, the twice the middle term, and then and the square and the radical goes from that, so you are left with x plus c quantity squared plus y squared. If you expand that, you get x squared plus 2xc plus c squared plus y squared. So x squared plus 2xc plus c squared plus y squared. This is what you get. Now if you look at this closely, right, okay, you will see that and in order to look at closely, I'm going to erase these things, right? You will see a lot of things get cancelled off. The x squared gets cancelled off, right? So you can say that the x squared actually gets cancelled off. And what else gets cancelled off? The y squared gets cancelled off. The c squared gets cancelled off. Okay. And then what do you have here? So you have, if you take the square root onto this side, you get 4a square root x plus c squared plus y squared. And if you take, and there is a 4a squared on this side, and you have, can you see a 2x, 2cx and a negative 2cx? If I bring this onto this side, right, I get plus 4cx. So if I cancel the 4's, then I'm left with a times x plus c squared plus y squared, right? So x plus c squared plus y squared. 4 is cancelled. So a is there. A times x plus c squared plus y squared is equal to, on this side, what do I have? A squared plus cx. A squared plus cx. And now if I square it again, what do I get? So if I square it again, I get, so I will take square of this will be a squared. And when I square the square root will go off and I get x plus c squared plus y squared. And on this side, I get the square of this, which will be what? A to the fourth plus twice the middle term, twice a squared cx plus c squared x squared. So now, really, what happens now is this. So if you expand this, you get x squared plus 2 cx, right? So x squared plus 2x cx. Let me just erase this. Will be easy for you to probably understand this, right? If I erase this, right? Okay. So let's, okay. So if I expand this, I get a squared. And if I expand this, I get x squared plus 2cx plus c squared plus y squared, right? And that is y squared is equal to a to the 4 plus 2a squared cx plus c squared x squared. And now what I'm going to do is I'm going to take out, that's what you have here, right? Okay. Now I'm going to do is, you can see there's a, I'm going to bring a squared x squared coming from this. And there is a c squared x squared. I'm going to bring down to one side. So I get x squared x squared minus c squared x squared. So that's taken care of these two. What else is there? I can see an a squared y squared, and that's this one, right? So this taken care of. So what else is there? So you can see that there is a 2a squared cx and a 2a squared cx. So those get cancelled off, right? Okay. And then you will have an a to the fourth on this side. That is that. And then you will see an a squared c squared on this side, and that I take onto the other side, I squared a squared c squared. I'm sorry, this is a long calculation, but then you need that to get the answer. So now from these two, I'm going to factor out an x squared. So if I factor out x squared, I get a squared minus c squared plus a squared y squared is equal to, I can factor out a squared from this, and I get a squared, a to the fourth a squared minus c squared. That's what I get here. So now what I'm going to do is actually I'm going to call this b squared. I'm going to call a squared minus c squared as b squared. Can I do that? Yeah, of course I can do that, because we know from the triangle inequality, right? Okay, we know that that if you take 2c, the distance of these two, and 2a, the length of the sides, we know that the diagonal, right, okay, is less than or equal to, so c has to be less than or equal to a, because 2c has to be less than or equal to the two sides, which is 2a. The sum of these two is 2a. Remember, that's how we started, by putting the sum, and 2c has to be equal. So a is greater than c, right? Okay, and that means a squared minus c squared has to be positive, because this is a positive entity. Okay, and because of that, okay, because Again, a C is the diagonal, right, of the triangle, and A is the 2A. 2C is the diagonal, and A is the sum of the two sides, 2A. So, C is less than A, right? Okay. And therefore, we can, this quantity is positive. Because it is positive, you can call it B squared. Okay. And now, that's from geometry. So now we are going to substitute A squared and A squared minus C squared as B squared. So you get a nice expression, B squared x squared plus A squared uh, y squared. Okay. So B y squared. Y squared is equal to, on this side, because A squared minus C squared is B squared, we are going to call it A squared times B squared. So A squared minus B. So we have B squared x squared plus A squared y squared is equal to A squared B squared. And then if you divide out by A squared B squared, right, then if you divide out by A squared B squared, right, the B squared will cancel off and you get A squared at the bottom. And when you divide this by A squared B squared, A squared will cancel off and you get a B squared at the bottom. And when you divide this by A squared B squared, you get 1. So this is the equation. After all that hassle, right, we managed to get the equation of the ellipse. Okay, so that's the equation of the ellipse. And there are two possibilities which are open when A is greater than or equal to B. That means I always think of it like when the stuff inside the X is greater than the stuff inside the B, then it's a scenario that we describe and we get a flat ellipse like that, right? Okay. All right, where the focus is like that, right? Okay. Because remember, we need the B to be positive, right? Okay. So A squared minus C squared has to be positive, right? So, but on the other hand, if the stuff inside the underneath the Y is bigger than the stuff underneath the A, right? Okay. Okay, then we will have a ellipse like this, right? Which is a more slimmer, right? Or more vertical type of ellipse, right? Okay. So remember when the stuff inside the X is bigger, this stuff inside the Y is bigger, this, and the focus when stuff inside the X is bigger, the foci is along the X-axis. When the stuff inside the Y is bigger, the foci is along the Y-axis. Okay. And so then let's do a quick question that we want to sketch the graph of 9x squared plus 10y squared equals 144. So this is not given in the standard format. The standard format is to be x squared under some square plus y squared under some squared equals 1. Okay. So we need to bring it to that standard format. So we need to divide by the 144 so that it becomes 1. We need to have right side. On the right side, we need to have 1. So we divide by 1. So we divide out. So when we divide by 144, you get 9 over 144 x squared plus 16 over 144 y squared equals 1. So now 9 times 1 is 1, 9 times 16 is 144, so we have 1 over 16 x squared plus 16 times 1 is 16, 16 times 9 is 144, so we are 9 over 9, y squared equals 1. So now if you bring it nicely as a square, you get x squared over 4 squared plus y squared over 3 squared equals 1. So it is in this form x squared equal, yeah, over by a something squared plus y squared or another thing squared is equal to 1. And so whatever that is under the x squared, x is bigger than what is under the y. So 4 is greater than 3. So we get a flatter ellipse. So we know that, so because 4 is greater than 3, we need a flat ellipse, right? And we need to find the focus now, right? So so the ellipse will be like that. So this distance will be a, right? It's called the major axis, and this is called the minor axis. So the major axis is, we know, should be 4, right? That is A, right? Okay, 4. And the minor axis is actually uh, 3, the other one, right? Okay, so 3, so that is 3, but we still need to find the foci, right? So how do you find the foci? We go to the formula where we found the C, right? C is equal to A squared minus B squared. Where did we get the formula? Remember, we started where we put b squared is equal to a squared minus c squared. So if you solve this for c squared, you get c squared is equal to a squared minus b squared. So, and we get that, and then we know that a squared, which is the stuff under the a squared under the x squared, which is 16, minus b squared, which is stuff under the y squared, which is 9, is 7, right? And so c squared is equal to 7, which gives you c is equal to plus or minus square root 7. So the foci are the negative square root 70 and positive square root 70, which is about 2 point something. So you can see that, so this is like 2, the foci will be like that, right? Okay. And foci will be like that, right? Okay. And so then this will be the ellipse. Okay. And that's it for this video. Thanks for watching.